Hi guys, today I will use this 110 GHz signal generator and signal analyzer to demo the test. This laptop can simultaneously display and record the analyzer's screen. This signal generator covers from 6 kHz to 110 GHz. You can see each connector is 1.0 mm male. This is high-end spectrum signal analyzer with 15.6 touchscreen and 5U height. The front and rear handle design makes the transportation easier. The hidden area on the left can list the current configurations. On the top are different function menus. On the right are the system shortcuts. This serial analyzer covers from 2 Hz to 110 GHz. There are 2 separate RF input ports. One is 1.85 mm and the other is 1.0 mm. We choose RF input 2 as the input and use a 1.0 mm cable to connect the 2 instruments. We set the frequency to 110 GHz with 2 dBm output power. You can see the peak frequency and power here. We set the center frequency to 60 GHz and the span to 100 GHz. Now the displayed frequency is from 10 GHz to 110 GHz. We set the RBW to 3 MHz to speed up the process. The peak remains at 110 GHz. We change the center frequency back to 110 GHz and the span is set to 2.4 GHz automatically. So the end frequency is 111.2 GHz. We click this plus to enable other functions such as spectrum analyzer, IQ analyzer, vector signal generator, W-line, 5G NR, analog demodulation, and so on. We choose the phase noise measurement function and click New. We set the center frequency to 110 GHz. Set the start offset to 10 Hz. We drag the curve down a little. We can see the signal's phase noise now. We choose back to the normal spectrum analyzer screen. We set the signal generator's output power to minus 60 dBm. The analyzer's reference level is minus 10 dBm and RBW is 10 kHz. We decrease the output power to minus 17 dBm now. We further decrease the RBW to 1 kHz to 500 Hz to 20 Hz now. We can see the scanning speed is very slow. We set the span to 20 MHz. To 2 MHz, 1 MHz, 500 kHz, 100 kHz, 50 kHz. We find the peak and set the marker to center. Here are the current configurations. Now let's test a pulse modulated signal using the gate function. We set the signal generator's output to 100 GHz. The spectrum is stable now. We turn on the pulse modulation with 200 microsecond period and 100 microsecond pulse width. The display is not stable. We press trigger and select gate label. We switch on to preview the gate. We set the trigger source to external 1 and drag the gate's start and stop line. The sweep time is set to 200 microseconds for clear gate definition. Then we switch on the gate function, thus we get a stable spectrum for the 100 GHz carrier. We can also use the pulse analyzer function to get more information about this pulsed signal. We press plus and select the pulse analyzer. We set the signal frequency to 100 GHz. The trigger source is set to external 1. The measurement time should be set greater than the duration of the period. Here we set it to 600 microseconds to get 3 pulses. We can double-click the small parameter window. The full screen can display all the amplitude and time parameters, such as pulse power, period, width, duty cycle, rise for time, and so on. Of course, we can also use power trigger to make the measurement. The trigger level is -25 dBm. That's all for today's test.